Suppose we want to find sum of coefficients put x equal to 1. Next bit is a1 plus a3. Put x equal to -1. Left side is 1. a0 minus a1 plus a2 minus a2n. To add up, subtracting, because we want a1 plus a2, a1 plus a3, odd terms. To the power n minus 1 equals 2 times of a1 obviously 2n minus 1. From here we have to the power n minus 1 by 2. To here you have completed first bit, second bit over first bit, second bit. Now, third bit is a0 square okay. Third bit. Replace x, y minus 1 by x. 1 minus 1 by x plus 1 by x square equals a0 a0 if you take LCM 1 minus x plus x square to the power n. This is first, second. Okay. Now multiplying 1 and 2. See, if you multiply first series and second series, what is the coefficient of x to the power 2n? a0 square minus a1 square plus a2 square. So saying multiplying 1 and 2.
Yes, sir.
This polynomial and second polynomial, and right side take coefficient of x to the power 2n. What will be coefficient of x to the power 2n? a0 square minus a1 square. Look at this. X to the power 2n. Multiply
Yes,
this term. Okay. So I'm writing multiplying. The board is visible.
Yes,
And equating coefficients of coefficients of x to the power 2n both sides. Okay. If two polynomials are identically equal, their corresponding coefficients are equal. Okay. So what will be RHS? A0 square minus A1 square plus A2 square, so plus A2n square. This is RHS. Multiply this and this, you will get a 2n degree polynomial. We'll get a 4n degree polynomial. This into this, x to the power 4n. Multiplying 1 and 2 corresponding sides, both sides will be a 4n degree polynomial and both sides are equal. So their corresponding coefficients are equal. The coefficients of x to the power 2n RHS is this into this A0 square plus.
तो 100 बोलते हैं उतना लोग आको बहुत से 100 लोग आको आगम कर
Up to here, this is okay. Any doubt? Any doubt up to here?
Yes.
Shall I rub it?
1 minute.
See, this is identity true for Mohammed Jasim.
Sir, no, sir, not my mic, sir. Some other voice.
But you are not muted.
Now, yes, sir.
See, this is an identity. It's true for all x. Whatever value we want to solve our purpose, we can assign. Both sides will be equal. So shall I rub it?
Yes, sir.
LHS. Coefficient of x to the power 2n in 1 plus x square to the power n into 1 minus x plus x square to the power n equals coefficient of x to the power 2n in 1 plus x square x to the power 4 to the power n. Okay. See, this expression is factorizable. What are the factors of this expression? This into this. Forget power. Power is same. 1 plus x square plus x power 4 is this into this. You are aware of this?
Yes.
Just I'm writing. Okay. This equals x square plus x plus 1 into x square minus x plus 1. Now this is same as coefficient of x to the power n. Here 2n, here n. So just I am replacing x square by x. Whatever will be the coefficient of x to the power 2n here, same coefficient will be x to the power n here. It's just replacing x square by x. Okay, both, and this is nothing but an, the given polynomial. This polynomial equals a0 plus a1x plus a2 x square. Okay, from there What is the coefficient of x to the power n? An. Look at this step. Whatever will be the coefficient of x to the power 2n here, the same coefficient will be x to the power n because I have replaced x square by x. Okay. Fourth bit. Shall I rub it?
1 minute, sir.
हो जाए तो बता देना. Shall I rub it?
Yes, sir.
Fourth bit. Replace x by 1 by x. 1 plus 1 by x plus 1 by x square to the power n. A naught plus a1 by x a2n by x to the power 2n. Take LCM. Denominator part will be x to the power 2n. Right side also it will be x to the power 2n. So left hand side is same. A naught x to the power 2n. A1 x to the power 2n minus 1. A2 x to the power A2n. See, left hand side of 1 and 3, name it 3. Left hand side of 1 and 3 is same, so right side has to be same. So 1 and 2 represent the same polynomial. Their corresponding coefficients will be same. Okay. These two polynomials are identically equal. Therefore, their corresponding coefficients has to be equal. So what is constant term here? Not a naught. Here a2n. Okay. I repeat, if two polynomials are identically same, their corresponding coefficients are same. So corresponding coefficients of 1 and 2 are same. So this implies a naught equal to a2n, a1 equal to a2n minus 1, an minus 1 equal to an plus 1, adding one extra term. Okay. So what we have to prove? A naught plus 1 up to an. Okay. Now we know that a naught plus a1 plus a2 to an plus a1 equals 3 to the power n. Just by putting x equal to 1, we will get it. Now, value of these terms, and if you add one extra an, and value of these coefficients are same from here. Same or not? Number of terms here are 2n plus 1 odd. So adding one extra an, so sum of these coefficients, sum of first n plus 1 coefficients, after adding this an extra, it will be, we have added an there, so here also we have to add. Sum of these first an terms will be equal to sum of last an terms, n plus 1 terms. Now I can write it 2 times of a0 plus a1 up to an. To the power n plus an. Now this is a0 plus a1 to an equals 3 to the power n plus an by 2.
Sir, you are muted, sir.
Any doubt anywhere?
No doubts. Yeah.
Shall I
No,
run
sir.
it?
Yes.
Yes, sir.
So this part is over. Next, sum of binomial coefficients. Here CR equals NCR. Okay, in short, we write like this. So this identity, put x equal to 1, 2 to the power n equal to C0, C1 to Cn. Put x equal to -1. Here we will put x minus 1. So this will be 0. 0 equals C0 minus C1 plus C2 minus C3. So depending on n, whether it is even or odd, accordingly, sign will be. Third, from here I can write sum of even binomial coefficients equals sum of odd binomial coefficients. from here only? Sum of
Yes.
even binomial coefficients equals sum of odd binomial coefficients. Now, see, this is an identity. If we differentiate this both sides, it remains same. Sorry, it remains identity. With respect to x. Differentiating both sides with respect to x, we have now this is also identity. Okay. After differentiating whatever expression we are getting, there is also an identity. Okay. So if you put x equal to 1, there is also identity putting x equal to 1, n into to the power n equals, sorry, n minus 1. Here n into 1 plus x to the power n minus 1 equals c1 plus twice c2 plus thrice c3 and cn. This value equal to this. So what we observe, suppose there is no binomial coefficients are not multiplied by any constants. Simply you have to put here either 1 minus 1, whatever we want to prove. If binomial coefficients are multiplied by some constant, it means we have to differentiate the series. Okay, this series. This is identity. If binomial coefficients are multiplied by some constants, we have to differentiate this basic series expansion. So up to here you have written. Shall I rub it?
For 1 minute. Done, sir.
Okay. Next. C0 plus twice C1 plus thrice C2. Find this value. It's 3 into NC2, meaning is that. See, one thing is here binomial coefficients are multiplied some integer, so we have to differentiate the series, that series. Okay. But if you differentiate directly, we'll get here only C1. We won't get C0. 1 plus x to the power n equals C0 plus C1x, C2x square, Cn x to the power n. Okay. Now we want this term C0. So if you differentiate directly, it will vanish. So we have to multiply by x so that this term, after differentiating, this term will be there. So multiplying both sides by x. So this becomes 1 plus x to the power n plus 1 into x. C0 plus C1x square, C2x cube, C3x to the power 4, x to the power n plus 1. Now, if we differentiate and then put x equal to 1, we'll get it.
Sir, we will get C0 x also, no, sir?
Correct. Differentiating respect to x, both sides. So this will be in 1 plus x to the power n minus 1 into x plus 1 plus x UV rule, this into derivative of this plus this into derivative of this, equals C0 plus twice C1x plus thrice C2x square from n plus 1 into Cn x to the power n. Here n plus 1 into NCn, meaning is that. Okay. Now, if you put x equal to 1, we'll get this.
Yes, sir.
So put x equal to 1. So just by seeing that, we can think of that what we need to do, whether we have to differentiate directly or whether we have to differentiate after multiplying some variable. So RHS equals C0 plus 2 into C1, 3 into C2, n plus 1 into Cn. Okay. LHS equal to n into 2 to the power n plus 1, n minus 1, n into 2 to the power n minus 1, 1 plus 2 to the power n. 2 to the power n minus 1 outside, n plus 2. So this is the answer. So what is the answer?
2 to the power n minus 1 into
N minus 1.
n.
Okay. So by observing the given expression, we can decide that what we need to do.
Yes, sir.
Completed.
Yes, sir.
Next, similar, do it. C3 plus 2 times of C4 plus 3 times of C5 plus n minus 2 times of Cn equals. Find this value हुआ कुछ? Any answer?
Sir, doing, sir.
C3 plus 2, C4. See, we don't want up to the coefficients up to here. Okay? The term up to here we don't want. And from here we want, means the power of this term must be 1. This is C0 is n, C0 is 1, and C1 is n. So let us do one thing, 1 plus x to the power n minus 1 minus nx. This is 1, this is nc1 is n. nc1 is how much? N. So
N.
sending these two terms left hand side, and we don't want x square because when we differentiate, one thing is clear that we have to differentiate. We have to
Yes, sir.
differentiate because coefficients are multiplied by some constant. And but we can't differentiate directly. We need to do some manipulation. So we don't want these two terms sending it left hand side. Now we don't want, after differentiating, this term should vanish. So this should be constant. So dividing by x square. Dividing by x square equals C2 plus C3x plus C4x square. So plus Cn x to the power n minus 2. Now if you differentiate and put x equal to 1, we'll get it. After differentiating and then putting x equal to 1, first we have to see what we need to prove. What kind of expression we have. We have to bring this in that form. Okay? Differentiating both sides with respect to x. Respect to x, then put x equal to 1. And writing directly, this will vanish. This will be C3, 2 into C4x.
Got it.
Okay. So RHS equal to C3 plus 2 into C4, so on, n minus 2 into x to the power n minus 2 into Cn. This is RHS, same thing. Now we have to simplify LHS. First we have to differentiate it and then putting x equal to 1. So to differentiate, we have to apply u by v rule, quotient rule. RHS. And dash. Now putting x equal to 1, this will be n into 2 to the power n minus 1 minus n minus 2 into 2 to the power n minus 1 minus n. Okay. Shall I rub it?
1 minute, sir. Done, sir.
So simplifying n into 2 to the power n minus 1 minus 2 to the power n plus 1 minus plus 2n means plus n minus 3 plus n minus 3. Now 2 to the power n minus 1 common n minus 4 plus n minus 3. चेक करो एक बार. Here, sorry, here plus 2 ना, plus 2n minus n plus 2. Mohammed Jasim,
Sir, sorry, sir. Sorry, sir. By mistake, sir.
n plus 2. That's it.
Yes, sir.
The same thing we need to prove. Shall I rub it?
Yes, sir.
Next, come to multiplication. Find the value of C0 square minus C1 square. This sometimes we need to remember because it will come again and again. C0 square minus C1 square plus C2 square. C0 square. The very first question today we have discussed
Yes, sir.
that A0 square minus A1 square plus A2 square. There we have to multiply two series. There we have to multiply two series. Okay. Binomial coefficients are multiplied C0 square. Okay. So whatever we need to prove, we have to take the basic series. Consider 1 plus x to the power n equals C0 C1x plus C2x square. Okay. Now alternately minus, wait. It is plus C0 square plus C1 square up to C, then we will come to
Replace by
C0 square. This is, here it is plus C0 square plus C1 square. Now write it in the form x plus 1 to the power n. C0 x to the power n, C1 x to the power n minus 1, C2 x to the power n minus 2 plus Cn. Now if you multiply 1 and 2 and equating the coefficient of x to the power n, multiplying this and this, what will be the coefficient of x to the power n? C0 square plus C1 square plus C2 square and so on.
Yes, sir.
Multiplying 1 and 2, we'll get a 2n degree polynomial, and both sides will equate coefficient of x to the power n. Multiplying 1 and 2 corresponding sides, and equating coefficients of x to the power n both sides. RHS equal to C0 square plus LHS, coefficient of x to the power n. 1 plus x to the power 2n. This into this. This is 1 plus x, 1 plus x. 1 plus x to the power 2n. That is 2n Cn. That is how much? 2n Cn. ठीक है, रब करूं
1 minute. Done, sir.
okay. Doubt anywhere?
Sir, clear.
So 1 minute, sir. Please don't drop that last. Thanks.
Next, try this C0 square plus twice C1 square plus thrice C2 square and plus 1 Cn square. Find this value. I'm giving you a hint. Here, binomial coefficients are multiplied by some constant. Means we have to differentiate. And here is square. Means we have to multiply two series. So simply if you multiply, we won't get the answer, but we have to differentiate one and then multiply. Okay? And this term should not vanish after differentiating. C0. Think of.
So that last two lines are completed.
Last.
Sir, completed, sir. Completed, right? Yes.
Okay. See, if any one of you have any doubt in question paper, you just send me question number. Okay. In my WhatsApp,
Okay.
I will discuss tomorrow.
Yes.
This one more you try. Also find this spelling. Alternately minus. Okay, you just write the question and try it, discuss tomorrow. You know my WhatsApp number?
Yes,
If
sir.
you have any doubt in question paper, you send me in my WhatsApp question number, I will discuss tomorrow, okay?
Yes, sir.
Yes, sir.
Okay, I'm disconnecting. Shall I disconnect?
Yes, sir.